Welcome to 7-1 Part B. Today we're going to be going from slope-intercept form to a graph. So today we're going to be able to graph an equation in slope-intercept form and manipulate an equation into slope-intercept form. So slope-intercept form is what we worked with yesterday, the y equals mx plus b. Okay, m is the slope, b is the y-intercept. So don't just say intercept because there's x-intercept, it could be intercepting something else, okay? So you need to know a slope-intercept form, which is that, okay? And literal equations, which just means equations that have more than one variable in them. So today they have it both an x and a y. So flashback to circuit 5, I want to say. We worked with direct variation equations, which was just y equals mx. And we knew with this equation, it always went through 0, 0. So we start at 0, 0. And then we're going to rise and run. And our rise and our run is our m. Whoops. I said m and then I wrote m. Okay, and our m is negative 1/4. So we want to rise 1 and run 4, and because it's negative, we want it to go downhill. So when I start at my point here, I'm going to rise 1, and then I'm going to run 4. If I go this way, it's going to go uphill. So I want it to go downhill, so I have to run to the left. So up 1, over 1, 2, 3, 4. Okay, another way I could have done that is by going down 1, and then right 1, 2, 3, 4. As long as it's going down that nice negative slope. And again, we're working with linear equations, so we're going to draw a line through our linear equations, and then we're done. That was easy peasy. So today is really similar to that. It's just that our starting point is going to change because now we have this number we're adding on. We have a different y-intercept. This y-intercept is 0, 0. It crosses the y-axis at 0. Now we have a different y-intercept. So here we go with our first problem. It says graph the equation y equals negative 3/4 x minus 1. So first thing I'm going to do is right underneath that I'm going to write y equals mx plus b. Okay, my slope is the m, my y-intercept is the b. So my m right here, it's right on top of each other. My m is negative 3/4. I need to keep that negative with that. Okay, m is negative 3/4. And then my b is my y-intercept. So with my b, it's not only just the 1, but notice how this had a plus here? So that minus kind of goes with that. It's going to be a negative 1. That turned out really weird looking, but that's okay. Okay, so our y-intercept is going to be 0, negative 1. So our first step here is instead of plotting 0, 0, it doesn't go through 0, 0 this time. It goes through 0, negative 1. And we always plot that on the y-axis. Y-axis is the one that goes straight up and down. So this is my y. So I'm going to start at 0, and it says negative 1. If I go left 1, that's my x-axis. I want to be on this one here. If it helps, take a highlighter and highlight that y-axis so you know where you're starting. Okay, so I'm going to start at 0, negative 1. Make a nice point there. I'm going to do that in black is what I meant to do. Okay, and now we have our rise and our run. We're going to use our slope. So our rise and run is negative 3/4. Okay, so from this point, we're going to jump up 1, 2, 3, and that's a negative slope, so we're going to go right or left. 1, 2, 3, 4. We're going to put a point right there. 1, 2, 3 over 1, 2, 3, 4. Okay, the other way we could have done it is by going down 3/4. So we go down 1, 2, 3, over 1, 2, 3, 4. Okay, linear equation makes a nice line. So if somebody ever asks you if it's a linear equation, check and see does it make a line. If it makes a line, the answer is yes. And that's our answer. Our goal is to graph the line, and there's our line. Okay, so for number 2, we're going to graph this equation, y equals 2 plus 3x. So first thing I'm going to do is write my equation y equals mx plus b. This doesn't quite look the same here. So let's think about that. If I'm going to identify my slope, my m, and then identify my y-intercept, my b, my m is right next to the x. It goes mx. So I want to think which part here is next to the x, and it's not the 2. So it might be helpful for us to rewrite this. We're just going to use our commutative property and switch these two things around. So I'm going to put the 3x first, and then the plus 2. Okay. Now I can see my m is really 3. So my slope is 3. My y-intercept is the b. So b is what I'm adding on, and this time it is a plus, so it's going to stay positive. So positive 2. So 0, 2. Our y-intercept goes on the y-axis. Okay, so that's our first thing to do. We're going to plot that y-intercept on the y-axis. So that's 0, positive 2. So I start at 0. Here's my y-axis. If you need to highlight it, maybe do a little bit better job than I did. Cool. Okay, 0, 2 would be 0, and then up 1, 2. Now we're going to use our rise and our run. So our slope is just 3. So I need to think, how can I write 3 as a fraction? Well, anytime I have a fraction, I can do 3 over 1. Or anytime I have a whole number. I can't talk today. So from this point, we're going to rise up 1, 2, 3, and then we're running 1. It's a positive slope, so we want it to go uphill. Puff, puff, positive. So this way. Just 1. Okay, if we want to go in the other direction, we can, just to make that nice straight line. So we go down 1, 2, 3, over 1. I could even do that again. Down 1, 2, 3, over 1. Draw our nice line through those points. Arrows on both sides. Life is good. All right, we have one more example. So in example 3, well, if we look at this, this doesn't even look like, we want it to look like y equals mx plus b. This isn't even close. Okay, the x is on this side, here's the y. We want y completely by itself. So first step we're going to do is solve for y. Right? When we solve for y, we're using our inverse operations. We're thinking, who's the best friend of the y? Well, that's -5, so we're going to keep that -5 with the y. We're going to get rid of this positive 4x. So to undo a positive 4x, we're going to say minus 4x. And if we do it on one side, do it on the other. Okay, we bring down this -5y. The 4x's are gone. So -5y equals, I'm going to write this 4x first because we want mx plus b. We can't combine these because they are not like terms. So we're going to say -4x plus 15. Remember, that's why we call them literal equations. Now to undo multiplying by -5, we divide by -5. Over here, we're going to divide each part by -5. Okay, and our final answer would be y equals, now -4 over -5, if I go to Desmos and I do -4 over -5, it gives me a decimal. So I just want the fraction, so I can either hit that fraction to get a simplified fraction, or I can think a negative divided by a negative is a positive. So it's going to be +4 over 5. Okay, x just goes boop off to the side. And then 15 divided by -5 is going to be -3. Now we have y equals mx plus b. So my m, my slope, which is right next to that x, is 4/5. My y-intercept is b, and b is what we're adding on, and this time we're adding on a -3. So as an ordered pair, it's going to go 0, -3. So step 1, we're going to plot step 2 now. We're going to plot the y-intercept on the y-axis. This is our y-axis. We're going to highlight it if we would like to. A little crooked, but that's okay. All right, 0, -3 means I'm going to start at 0 and go down 1, 2, 3, and I want it to be on that y-axis. Now we're going to use our slope. Our slope here we said was 4/5. So 4/5. So we're going to rise 4, run 5, and it's puff, puff, positive. So we want it to go uphill. So up 1, 2, 3, 4, over 1, 2, 3, 4, 5. Okay, and if I go up 4, I can't go over 5, I can't go down 4, so we just have those 2 points. So we just make a nice line through those points. And then they live happily ever after. Voila. Life is good. Alright, so for our summary, we have in the equation, so the equation was y equals mx plus b. And that is slope-intercept form. We call it slope-intercept. This is genius, I know. Because there's a slope, m, and an intercept, b. So m, we said, is slope. And then b isn't just an intercept, though. We want to make sure we identify that as the y-intercept. So once we have that in that form, we plot the y-intercept. Okay, remember that means it's on the y-axis. Okay, then we're going to use the slope to rise and run. And that's it.